So welcome to the short video post, which is about the recent blog post at THNG, and it's about the added support for ESP32, the WebThing API, and PlatformIO-style projects. So we have here the board to program. It's an ESP32 from Espressif Systems, and Espressif had a huge success with their ESP8266, where a lot of libraries and board support exist. And now this is the ESP32, its successor, with more speed, more I/O, and a bit more memory. And what you see here is the Room32 module on this Node MCU. So that's the whole board connected by USB on a base shield with Grove connectors and a small LED from the Grove kit. So that's what we're going to test with ESP32. Yeah, and there's the WebThing API, which is worked out by Mozilla. And in the end, it's about programming devices in HTTP in a REST style with JSON API. And they're trying to sort of standardize the access to devices. So if you want to take a look at that, iotmozilla.org. And PlatformIO. It's in the end, it's an ecosystem for IoT development, and it works for quite many embedded boards and platforms and IDEs as well. So looking at development platforms, we'll find the Espressif32, and you can have a look at the Boards Explorer. So currently there's roughly 30 boards, 30 or so boards that are supported by PlatformIO. And yeah, good point. Let's look at ours, Node MCU. Yeah, there it is, Node MCU 32S. That's what we're going to use. So yeah, let's get started. We're going to start on our own site, THNG.online, which is a code generator. So hit the Get Started button, and we create a new thing description, and we're going to call it ESP32 LED, and we are able to select a type, and there are some predefined types which render predefined properties or actions, and I select the on-off light and hit Next. And we have several generator modules available for Arduino, for ESP8266, and for ESP32. And you can have a look at the dependencies. Here it works with Arduino JSON. Of course, the ESP32 core for Arduino, circular buffer to store some things, and the ESP async web server and async TCP. So let's use this module. The properties block is already pre-filled with the on property, which is a Boolean property. So yeah, turn it on or off. And roughly that's about it. That's what we're going to need. So we could add more properties here or change the existing, but we don't, since that's sufficient for us. Let's continue to actions. Actions are not predefined, but I'd like to define one. And I call it flash once. I already did that. So flash LED one time. Okay. Events. Could add events here, but I choose not to because I don't need that at the moment. Okay, hit the generate button. Here I can review what I've chosen so far and change if I want to, but I don't want to. That's fine as it is. Okay, hit the generate button. And what it does, it generates a bunch of files for us. And this is part of the refactoring of that module in the existing modules for Arduino and the ESP8266. Typically there was a single file, sketch.ino, where all the code is in, so you can easily copy and paste a single file into the Arduino IDE, which makes the file rather big and not so easy to handle. So I've chosen to refactor this a bit and have several files for distinct purposes like HTTP handling or application handling. And of course there's a README with setup instructions. You can take a look at that, and it tells you what to do, not in all the details comparable to a tutorial, but in short. So, and yeah, we're going to take these files and put them into a PlatformIO project and compile it and see what happens. Okay, so I'll take a terminal, and first we need to create a new project. So I have PlatformIO installed. I've used the command line version. Say PIO init, and I need a board ID, which is this one, node MCU32S. 32S, and I'd like to integrate VS Code as the IDE. So this generates a bunch of files. It tells me what to do with it. First, there's a source folder and a library folder, which are empty initially, and a PlatformIO.ini, which is needed by PlatformIO to know for what board and framework I'd like to compile. So that's how it looks. Okay, now I'll go back to, that's the blog post. I go back to the source code, and I have the option to download all of these files at once as, I'll say, tarball. Download, do so, yeah, save the file, and now it's on my drive, and I can unpack it. And it has a name starting with this ID, which is the same as in the URL 6IFB. So go to the source folder, unpack from downloads the tar file, and that's what we have here. Okay. Now we need to make some modifications to that. The first is that I open this in VS Code, source folder, files in. The first is that this module relies on a bunch of libraries, and we need to add these libraries to our project so that PlatformIO is able to compile this. And you can find the dependent libraries in the README. And oh, here it is, add libraries, add the following libraries to the project. Two ways, either run separate commands or add a block of configuration text to the PlatformIO.ini file, which is what I do. I just copy this from here, open PlatformIO.ini, and just append it at the end. Okay. So, first thing. Then let's quickly walk through these files. There is a main.cpp, which contains the typical setup and loop code. Then there is http.cpp, which contains all the HTTP handling and callback handlers for the different functions. There's some WebThing helpers, which deal with actions and events and properties, and an application part and a config file. Let's look at the config. Typically, the config is good as it is with some sane defaults. What, of course, it cannot know is the SID and password of your Wi-Fi. And we have to add that here. Use this Wi-Fi settings. Okay. The rest is as is, but of course you can change things here. For example, if you do not wish to have debug, you can comment out some lines or the like. So, next part to look at is the application.cpp. It is constructed in a way that this file here, contains functions which are called back by the rest of the sketch whenever a WebThing action happens. For example, setting a property, triggering an action, etc. And for each property that has been defined in the web UI, there is a get method and a set method. So we had a property named on for the LED. So there is a get on and a set on function here. And there is an app setup, which is called during the setup process, and an app loop, which gets called by loop regularly. So to control our LED here, we need to first set the pin mode in app setup, and this is connected to pin GPIO 18. So I need to say pin mode 18 output. And then every time I want to request the state of the LED, I use digital read pin 18. And every time the LED, or say the on value is set, I redirect that to digital write on pin 18. Okay, great. So let's see if that works out. PIO run starts the compilation and linking process, and first it installs the missing libraries that were specified within PlatformIO.ini. Then it starts to compile all of that. take some time. Linking. Yeah, and we're done. Next step, which I could have issued already before. I upload this sketch to the board and directly afterwards connect to the serial monitor to see what's happening. Oh, no, it's not connected. Oh, yeah, totally right. So, connect USB. Try again. Good. So, it starts to connect to the Wi-Fi. It did connect, received an IP address. And that's what I wanted to know, the IP address. So let's ping this, check if it works. Great. So we can now curl to this device using HTTP 101. And within config.h, there is a URI path and prefix specified. So let's /WOT. Try this out. Yeah, and something comes back. This is the WebThing API thing description, and I can add some things here if you happen to have JQ installed, so that pretty prints it. And yeah, you can directly compare this to spec. It's an on-off light with the property on, and here you can see the URI under which this property can be reached, and our action here. We didn't implement the action for sake of brevity, but just go on with the property here. So I can insert that here. So now I curl for what/property/on. It tells me on is false. Okay, let's turn this actually on. So what I need to do here is change the HTTP method from GET to PUT, add a content type of application JSON, because we are sending JSON to the device, and then insert the JSON part here, which could be on equals true. And here you see it just turned on. I'll make it silent. Go back to false. True again, turn it on, and we can query the status, and it says on. Okay, so far for this tutorial. If you like to try this out, just go to thingstruction.online and hit the Get Started button, and yeah, start with creating your own thing descriptions.